As a kid, one of my favorite types of games were top-down shooters, when there is a single hero on the screen with hundreds of monsters and you just blast right through them. It was awesome. In fact, one of my first games that I ever played was Alien Shooter. So that's what we're gonna make today. Okay, so by the end of the video, your movements should look sort of like this. I mean, at least you can hope. Alright, so here's our model. If you want to know how to import a model from Sketch5 etc. to Unity and rig it using Mixamo, which is what we're gonna use, you can watch my video. It's gonna be on the card or something. And yeah, currently I'm just positioning the camera on a top-down position and just drag this. And yeah, other than that, I'm also gonna just drag and drop a gun so that we know what's the front of our character. Let's extend this, and I'm gonna drag and drop it to the right hand. And now we have to basically position, rotation, scale this so it fits correctly. And there we go. Now we already have one animation, the idle aiming animation, which yeah, let's turn on the loop time. And now we're gonna need these animations, the ones you can see on your screen. These are all the animations that I'm gonna use. Here we go, these are all the animations, and we can just Ctrl D to duplicate them and have them in our scene, and then we can just delete the FBX. There we go. Now it's time to make an animator, so that can just drag and drop the idle aiming animation, and we can go to animator, and there she is. Let's create a blend tree now. If you don't know about blend tree, don't worry, it's not going to be that difficult. It's pretty much like self-explanatory, but currently we need to create two parameters. One is horizontal and the other one is vertical. These are the two parameters that we are going to use to basically influence our animations. Let's open our blend tree, change this to 2D simple directional, and have horizontal and vertical parameters here. Let's create a motion field. Don't worry, motion basically means animation. Let's drag and drop the idle aiming animation, and let's drag and drop the rest of the animations. So yeah, it's a bit of a tedious process, but just follow me through this. Alright, so there we go. This is how your your blend tree should look like. And now you can see these positions, and position on X and position on Y. What these axes basically means is are basically the parameters. Like our horizontal parameters goes from left to right, and our vertical parameters goes up and down. So say the vertical goes to 1, then our position 1, like the position Y basically will represent 1. So yeah, in a nutshell, we basically want the walk forward to be at Y top, since our vertical movement will designate that. So yeah, I know it's kind of sounds a little bit confusing, but don't worry, once you get used to it, it's really simple. You won't even have to think about it much. So yeah, let's currently just position all of these accordingly. Now say an animation like walk forward left will obviously come in between forward and going left. So yeah, that's what we're doing. Alright, I think we are basically done with our blend tree, and this is how it should look at the end. And the red dot basically represents the two axes, basically the two parameters, the horizontal and vertical. Here's what we can do. We can basically drag this blend tree, this small animation. You can just tap here and click on play, and by this we can actually see the animator. We can move forward, towards right, left, center, back, left. You know the deal. It basically works. It looks good. It works fine. Yeah, we need to set this as a layer default, and we don't need the idle animation here. And just like that, yeah, we're good. Now that the animator is all set up, I think it's time to do some programming. Let's create a controller script and open in Visual Studio. Alright, so let me just explain this. We are basically taking a vector 2 moment. We are of course getting the input axis for horizontal and axis, horizontal and vertical, and just converting that to movement.x and movement.y. After that, we're simply just using the character controller to move the entire thing, using of course as a speed as a parameter. Lastly, we can simply just normalize the entire movement to ensure we have a consistent magnitude. And yeah, we are basically done with a simple character controller, and let's shift back to Unity. Alright, so there's our character, and let's first attach a character controller to it, and let's just simply rescale it. There we go. Yeah, that looks good. And yeah, now we can just simply drag and drop our script to the same. There we go. Yeah, let's drag that and change the speed. Yeah, I think the speed is 5, looks good, and we can just click on play. Alright, and yeah, it's working. I mean, what we designed it to do, it's currently doing it. And yeah, it works fine. Let's head back to the script and change a few more stuff. Alright, so let me just explain what this rotate towards mouse position method does. It of course handles rotating the character towards the mouse position. So in a nutshell, a ray cast is casted from the main camera towards the mouse position using a screen point to ray input dot mouse position. If the ray hits something within, like say 100 unit, currently it sets to 100 unit, look position vector is set to that hit point. Basically the hit point refers to the place where the mouse position hits the ground, and then of course the character is rotated towards the look direction using transform.lookAt. And in order to create the look direction, we simply subtract the character's position from the look position, with of course the y component set to 0 because we don't want to rotate in the y-axis. Now let's just call this method in the update method, and let's head back to Unity to see it working. And yeah, indeed, the character rotates towards the mouse position, and yeah, it basically works well whenever even when we are moving, the character still rotates towards the mouse position. Pretty cool. Okay, back to the script. Now here's the thing, if we simply just change those two parameters that we added in the animator, just like that, there will be some issues. But first thing, let's drag and drop the animator and click on play, and yeah, let's see. Okay, so first issue is that we haven't set the animations to loop. So first thing, let's set those up. Let's select all of our animations and switch on loop time. And while we're doing that, also we can change the animator a little bit so that basically the speed of our animations are a little bit faster. Yeah, 1.5 is good. That just basically increases all of the animation speed a little bit, you know. Okay, so yeah, if we keep our mouse towards the up point, you can see all the animations work fine. And the issue arises when we move the mouse. So yeah, now none of the animations work. The issue is that all the animations are currently working according to the world position, not our character's local position. So what we need to do is head back to script and change a few things. Okay, so this line of code is basically the holy grail, the most important line of code in this thing. The vector3 local move is created by converting the world movement vector to local movement relative to the character's rotation using the transform.inverse transform directions. And then finally we can use local move.x and local move.z for instead of the movement.x and movement.y. Let's head back to Unity. And yeah, let's click on play, and just like that, as you can see, it works fine, it looks fine. Yeah, it doesn't matter whatever your mouse position is, the animations work accordingly. And in the animator you can actually of course see all the animations working out, they're actually highlighted. One last thing that we need to add is a little bit of smoothing between the animations. So in the script we're just gonna change straight from localmove.x to mathf.lerb, which basically lerps between the two values using a multiplier. So yeah, the animation is just a little bit more smoother, and yeah, we can just simply modify this kind of like that. And yeah, let's head back to Unity and see it in work. And let's just modify the multiplier component a little bit so that the animations look fine. 0.05 works well. Yeah, yeah, that looks good. There's a little bit less jittering between the animations when you switch between them, especially the opposite animations like walk left and then straight to walk right, sort of like that. So yeah, it just looks a little bit better, and of course you can change the values accordingly. And yeah, I guess that would be just about it for this. Of course, if you want the camera script, how the camera script work, definitely drop a comment, drop a like, subscribe, and yeah, that would be just about it. That's all for now. See ya, peace out.